Hi everyone, good morning. Sunday morning, and it's a full room already, almost full room. I didn't expect that at all at 9 a.m. on a Sunday. Definitely, you're the 2% that's moving the world. You know, you've heard about the 2% who changed the world and all that. I'm not being sarcastic, I'm being honest. But thank you for that. Thank you for being here, and thank you for having me. Um, right before we start, I know it's a Sunday morning, I know you all would like to have your weekend the way you want it. So I'm trying to keep it a little bit balanced. I'm not going to bore you with all my detailed techie stuff, but at the same time, that's what we are here for. So I'll strike a balance. But before that, let's start with a little bit of breathing, shall we? Warming up to the day. Let's take a deep breath in, tummy out, inhale, exhale. Are you doing it? Inhale, exhale. Don't breathe on each other. You know, it's still COVID around, so inhale, exhale. Feeling better? A little bit warmed up? All right. So I'm here to set the keynote, set the tone for today's session, but I'd also like to talk about some of the things that are very close to my heart, starting from data, because I've been doing that all along, all the years of my career, and also talk about something around application development and other things that come along with it as a full stack developer, or even as a data engineer or data scientist. You all would know the importance of a lot of different aspects of software development these days, not just about coding, it's about a lot of other things as well, like DevOps, SRE, monitoring, logging, security, scalability, and all that. So we'll talk a little bit. I'm not going to talk about each one of these aspects. Don't look so scared. But there are certain aspects that I'd cover. And that said, there is a few hands-on sessions too, but I'm not going to go into that level of a detail or anything, but I'm going to show you how it can be done, so when you get back home or later today when you get a chance, you can go and try it out for yourselves, or at least have a starting point to do certain things on your own. Basically, if you have a data idea, how do you turn it into an application in less than, say, 30 minutes, and then have your team work on it. For example, this would really be useful for a budding entrepreneur who has a great data idea and who wants to actually work on it. Sorry, I'm not ignoring you guys. I'll stand in the middle. All right, but before we jump into all of that, I have a little bit of a puzzle for you. So we all know Andre Agassi and what, I mean, the initial days when they were like, he lost to Boris Becker 3 matches in a row. And he wanted to understand why. And he always thought that tennis is like problem solving, so he went ahead and watched a bunch of videos of Boris Becker trying to understand, like, I mean, him and Boris Becker, of course, he watched a bunch of videos and trying to understand what exactly he was doing wrong, that he continues to lose, and what is the thing, what is that magic formula that he can find out from the videos that will help him get past that hurdle. So the clue is in this clip. If anyone can guess what exactly he observed from the data that he looked at from the videos that made him win 9 of the next 10 matches in a row. Almost in a row, I think. Andre Agassi won 9 of the next 10 matches. And he found that secret formula. He found that thing. The clue's in this clip. Can you guess what he observed? Any tennis fans here? Okay, only one, but still, it's not about tennis. Like he says, it's not about tennis, it's about problem solving. So forget tennis, just look at the picture and sorry? Is it what? Grip. No, but that's one way to look at it, but no. It's not the grip. All right. 3, 2. Yeah. Yes. What did he find? What did he observe? Sorry? Sorry? Eye motion and movement. Not exactly. Confidence. We all should have, but that's not the answer. All right. Any last try before I tell you? What is it? The clue, the answer is right here. What is it? What is it? What is this? Nope. Nope. There is one specific answer. There's one specific thing that he observed from the videos, which is there in this clip. It's okay. So let me reveal the answer. I mean, I'm not. It's not my answer. It's just. He said it. Andrea Gesse said it. So I'm also like you. I would probably not have observed it, or rather, maybe I don't know. If I'm a tennis player, or if I'm observing something for more than like 100 times, I'd probably realize that he's doing that. If you notice, Boris Becker has his tongue out. He has his tongue out. You see that? So what Andrea Gesse observed was that every single time he serves from the deuce, and he's always like, if he's putting it to the center or to the body, he's always putting his tongue in the center out. If it's to the left or to the right, it means he's going to serve out wide. So he knows where exactly he's going to serve because that's his body language. He has this tick with his serves that he always puts his tongue out, and that's what Andrea Gesse observed while he was watching all that data to understand why exactly. I mean, it's not why exactly he's losing. It's something that he found that he can use to his advantage, that he can go ahead and win the next 10 matches or 9 matches out of the 10 and, go on to become world champion. So the reason why I told you this story today is we are all talking about data. We have a lot. I looked up the agenda, and I saw a lot of speakers talking about data, a lot of ML-related topics, AI topics, and even yesterday, there was a lot of discussion around that, I believe. So what I think is we all look at data in a different perspective, or in all the perspectives possible. No matter what your idea is, no matter what you want to innovate on, what you want to do your business around, data's important. Data is there. You build everything else around it. So what we do with the data is one thing, but what we observe the data, what kind of questions you ask about your business right before you start your business, or right before you start your project, or if you're a CTO, or if you're a technology architect, or if you're a data architect, data engineer, data scientist, no matter who you are, what questions do you ask that allows you to look at your business in a different perspective? That is really important. Like, what can you observe from the data that will set yourself apart and set your business up for success? That's really what's important. So before we go on to the next thing, this is something that I want to talk about how a bad user experience can be converted into a successful application or a business or an idea for your customers. But before that, I want to tell you this thing. So when I say, what kind of questions do you ask? Can I ask in the audience, it's not forgive me for my incessant poll taking right now, but I still want to understand how many data scientists, people who work around data here, not application developers, just data. All right? All right? And application developers, full stack? Wow, okay. Good that I asked it right now, otherwise you would be like, why are you talking to me about this all this time? All right. And what else? How many DevOps engineers? Okay, cool. And how many entrepreneurs? Nice. You all are together, or same company or different companies? Nice, nice, okay. And students? Oh, you're all students, great. Most of you, well, nice. And how many of you have used Google Cloud? All of you, great, amazing. All right, I'll stop with that now, with that nonsense right now. Anyway, so the reason I asked you these things is, of course, you're all students, some of you are working, some of you have businesses, most of you, like I saw a lot of hands up for entrepreneurs. So what I want to tell you is, before you do, if you're all technology entrepreneurs, I assume, right? So you have to ask questions around technology. You have to ask questions around your data. So let's say you're designing your database, or you're designing your application. What kind of design questions will you ask? This is not a poll, this is a serious question, just like the first one. What kind of questions will you ask? Like for me, I always start with 3 approaches. your business approach, business aspect, your technology aspect, and the entire design itself, the design of your application. So what kind of business questions do you ask? What is the purpose? Sorry? Customer? Customer needs. Exactly. So that is the requirement. That's the foundations of your business. How you're going to use the data. Exactly. The purpose of it. Scalability. Technology. Okay, right. Jumping right into technology aspects. What kind of transactions? Exactly. So the type of the data, the type of the data ingestion, what are the sources of data, what is the type of data that's coming in, what structure is your data in? Is it going to be videos, music, or is it going to be relational tabular data, or is it going to be document data? What kind of data is going to be ingested, right? Ingestion, structure, and what kind of transformations you need on the data, what kind of analytics, what kind of business intelligence questions your leadership wants on the data. What do you want to observe of the data that will enable you to strategize and provide more business value for yourself, for your product? So that is important, right? Those kind of questions you ask. And also design questions, like you said, scalability. How long do you want to store the data? What's your archival strategy? What's going to be your privacy or security regulations? What is the region you're going to apply this on? What are the other regulations and laws that you have to abide by? So many things. You have to ask the right questions, otherwise it'll happen like I did this morning. I got up, washed my hair to realize there is no hair dryer in the room. And that's why I look all disheveled. I mean, otherwise also I do, but I'm just saying. So that's how it is. Like, you plan for it beforehand, otherwise 6 months down the line, once you start building your product, that's when you'll realize, oh my God, I missed this. Now go back again from the scratch, change your database. How many times has it happened? Right? We change the design 6 months down the line. I'm not saying it's not going to happen if you answer all those questions, but you can set yourself up for success to a certain percentage and say that, okay, these are the questions and these are the things I've already addressed. So the reason I'm telling you about this is whatever we are going to look at today, think of it from the perspective of your business. Don't drive business with, don't just start with technology and say, okay, I have this, now what business can I do? Maybe if you're so sure and if you already have everything built out, but I would always recommend start with your business idea and then see what works for it. Drive your technology around the business, right? So that's how it should always be. So there is, again, a blog which I have linked to in the slides. Probably later on I'll share it with the host and they can share it with you. That there is a blog about foundations of database design. Or foundations of your app design. So you can take a look at that to address all the questions, the design questions that you may ask. I'm not going to go into more details on that. Okay, let me just take a step back here, or go back to what I said that I'm going to talk to you about. Look at this. This is a big chunk of data, big chunk of English language comment, feedback that a customer has left about what they feel about the service, right? You see, probably curse words are not there. I think I removed just for the sake of, being nice. But I think, I didn't write this. I mean, this is actual data which was publicly available, so I just took this. This is, I think, for a network provider in the US and an angry customer who is not at all satisfied. So this is the data that's coming in. It's, let's say, 1,000 lines of text. For that matter, if you are the engineer who's going to work on that, imagine that you're waking up every day to hundreds of such complaints, or even thousands for that matter. In case you have a big team, you probably have tens or hundreds of it. But imagine you have to read through all this and then provide service. How would you feel? It's frustrating, right? You have to first read through all that. You have to understand what it says. I know you all understand where I'm going with this, but before that, I want to just make you feel how annoying it is to go through the context like this and then have your team or yourself address that issue. So it's impossible. But imagine this being replaced with something like this. Ignore the genie lamp right there. That's just for ambience. But look at the content right there, where it is converting that 1,000, it has converted the 1,000 lines of text, or whatever number there was, into one line saying that this is the issue, right? And this is the solution, possibly one of the solutions you can look at. Now, this is experience. That is pain in the bee, right? and this is experience. So transforming this to this is one of the things I want to talk about. No matter what business you are in, you definitely have developer experience, you definitely have customer experience, and all these things that need to be delivered. So keep that in mind. I'm not saying you will stumble upon the same use case. I'm just saying think about it from the perspective of delivering experience as a service, and that is exactly what I'm going to talk about in a little bit, in a few slides later, in few slides up from now, and that's exactly what we're going to talk about and how we're going to do that with Google Cloud. Now, before we get into that, I know that it's all heavy, so I just want to look at 3 or 4 pipeline diagrams from the perspectives of different team members and different audience and different teams. The first question I asked you is how many are data engineers, how many are full stack developers and all that, right? So everything is being looked at in a different perspective. You saw how Andrea Gese looked at Boris Becker's body language and understood certain things from it. Similarly, your teams in your organization, as if you're an entrepreneur, or in your team, or in your company that you're working for, or even in a product that you're building as part of your university curriculum, what you'd be looking at is there are different teams or different people who are focusing on different aspects of delivery. The analytics team will be looking at a product pipeline or a data analytics pipeline in this manner. So they'll be looking at, okay, there is a big data warehouse, I have database. Database is important, agree, for everything, because you have data, you need to handle it. You need a database or a data warehouse, and how you're going to handle the rest of the pipeline. So it starts there, and they look at data processing as a big chunk, which is important to them because this is the entire data analytics pipeline. So data processing is important, feature engineering, let's just call it the ML thing, and then the training block and whatnot. So this is nobody's perspective yet. This is just a high-level overview. But now, this is the perspective of the ML ops team. So how does the operations team look at that? For them, it's a matter of, okay, you have database, you have storage, you have a data scientist team sitting there, you have an ML engineering team sitting there. That's all they care about, right? That's all they care about. So take a look at this perspective, a data scientist perspective. The same pipeline, this is how they look at that pipeline as. So they look at, okay, I have a database, I have storage, and then I have a dev environment where I'm building my data science thingy, and then I'm doing my ML pipeline definition, I have a feature store. So they have a little bit click down version of the data science block, right? And then source repository, because they're also writing code to deliver their ML results or whatnot. And then that's it. And then they hand it over to the ML engineer. They take it from there to automate it and further feed it back to the pipeline, right? So this is data scientist's perspective. Now, the data engineer's perspective, they look at even one click detailed. They look at data warehouse, database, that is storage, and everything that the data scientist does is consolidated and compiled in one block. And then they have all the things that they do, the CI/CD, the ML pipeline, automation, the triggers, and from there how they're extracting the data, validating, processing, all those things in one pipeline. And then they have the results delivered, and then they have whether it's going to be a batch or real time. So they think about all these details. So this is the perspective of an engineering team that you saw before. Now, all those put together, this is how your data warehouse or a solution, marketing data warehouse analytics architecture solution for your business would look like, ultimately. I'm not going to go into this architecture right now. I'm just showing to you. The reason I brought this out is for you to, I'm just dropping hints here and there so you get what you want from this. Because as a business owner, or as a technology enthusiast, or as a developer, or as an engineer, you look at, or as a data scientist, you look at things in different perspectives. So I'm just showing to you, if this is important to you, this is what you'd be looking at, all those perceptions. And this is, again, a consolidated view, talking about the sources, talking about the data processing steps, analytics steps, and then the insights and activation. That is the final end user delivery, right? That is what they feed back to the application or to the end users. So this is just an overview. Now, I just took a break for 4 slides just to go back to tell you this is the different perception that we are looking at. This has no connection to what we were looking at earlier, how to translate the 100 lines or 1,000 lines of customer complaint into a quality, meaningful one-line statement that will not only save time, but also solve the problem for you. But that will give you an insightful experience and a meaningful value to your time. So translating that is what we are going to look at, like delivering user experience as a service using Google Cloud. So what you saw in between that, the 4 slides, was just for you to, just knowledge nuggets for you to think through. If you are setting up your data center of excellence, or if you are starting a company, you have to think of those things. All right. So delivering user experience as a service. So some of the things that I'll be talking about today, BigQuery, of course, Vertex AI, Cloud Run. I will not go into details of Dialogflow and Data Studio because I don't have so much time as part of the keynote. It will be too detailed. But I just want to tell you that it is there and you can use it in your application. So BigQuery, we all know. How many of you have used BigQuery? Show of hands? OK, cool. So you can use it as a database itself, a data warehouse solution. You can use it as an analytics solution. You can use BigQuery's ML, AutoML, so many things. And any data analyst in the room who does not do any Python coding or anything, but do SQLs and all, good. So how would you like if I tell you, you can do ML without having to be a data scientist or without having to be a full stack developer or a Python developer? Would that make you happy? Would that engage you? Right? So anybody who's a data analyst can connect with me. So that's one of the things we'll look at. So it is possible with BigQuery. You can do your ML, AutoML, or manual ML. You can do that without having to do any Python code. You can just do in a matter of 5 queries to be precise. You can complete your ML model and deploy it. So that is, I mean, you can deploy it using other things, but with BigQuery, you can create your ML model and the table gets generated, right? So that is one thing. But here, in this architecture, it is being used as a warehouse database solution. And then Vertex AI, I'm using Vertex AI for delivering the ML solution. I'm using AutoML, which you'll also see in a little bit, a demo of what are the steps you can take to convert your chunk of text to classify that into a single label or a multi-label solution. And then Cloud Run. So Cloud Run is a blessing in disguise, I would say, because I've spent hours trying to build applications, full stack applications for that matter, deploying solutions in servers, I mean, even serverless for that matter. Nothing has been so effective. Like in under 2 minutes, I'm able to bring my application, a containerized application, of course, a stateless containerized application, and get it deployed in Cloud Run. So that's how simple it is. I get a URL immediately, and I can use it as an API to be consumed by a client application, or I can use it as a user interface that customers can use to play around with my application, right? That's how simple it is. Like in 2 minutes, you can deploy your idea or your application. No, first you have to convert your idea into application, and in 2 minutes you can build and deploy that using Cloud Run. So that is phenomenal. For me, that just blew my mind when I started working with it. And a lot of folks in the past that I've talked to, the developers, have been really impressed with it, especially the full stack developers who are struggling and thinking about, okay, how much time do I have to spend on this? When do I get my URL? How to consume that in my client application and all that? This is ideal for that. And then the laptop thingy over there is just to show that you have the web application over there. In this case, I think I'm using a Cloud Spanner Java Spring Boot application. That uses Cloud Spanner, in this case BigQuery as well, can be used, and then using Jib to build your container, and using Cloud Run to deploy that application. So that is the architecture. And Dialogflow is that little genie thing you saw in the beginning with the chatbot and everything. So Dialogflow can be used to build your interactive chatbot, creating intents. It's very easy. It's a matter of like 5 steps or 6 steps. I'm not going to go through the steps here for Dialogflow, but check it out. It's really fun to create your own chatbots using that. And then Data Studio is for analytics. You can also use Looker, which is really interesting as well, for visualizations, for understanding your data, for really making decisions out of your data. That's Data Studio and Looker. Now, I'm straight going to jump into the Vertex AI aspect of it. Vertex AI is the one that we are using for AutoML solution here. You can also customize it. You can make it manual AI solution as well. But in this case, I'm going to show you, even if you're not a data scientist, you have a data engineering team who can get the data, cleanse it, clean it for you, and then do the processing steps that's needed, prepare the data, and who can get the process automated, then you are good to go with Vertex AI without having any expertise, per se, in the data science area. So how I'm taking that chunk of data, classifying it into single label classifications using Vertex AI in 5 steps. So that's what you see here. Step 1 is to label your input file. I'll get into the detail of that. It sounds simple, but it has a little bit of depth to it. configuring your label text classification in Vertex AI, like how do you set it up? It's a matter of configuration, drag and drop and all that. And uploading your file and train the model, just click, a matter of 2 clicks, upload your file, train, and then evaluating your model. Your results are obtained once the model is trained, and then you click a button, evaluate your model, deploy and test your endpoint. Once you evaluate, you're happy, click deploy, you get your URL, the endpoint. How cool is that? That endpoint can then be used directly in your application. You just send requests, receive responses, that's it. Can you imagine if somebody told you that, I mean, you probably already have used it, some of you may have used it, and for some of you it may be new, but if you're a first-time user, you'd be mind blown. Because you don't even need to know, like you don't know whether I have to use lean, I mean, of course you need to know whether it's a classification problem or a regression problem, the basics, but then you don't need to know how will I fine-tune my parameters, what should I do? Should I do one-hot encoding? Should I encode this field, that field? No. I mean, just upload your data, the system will take care of it for you. If you're happy with the results, just deploy, and you can be the engineer that you are, take the URL, consume it in your client application, that's it, be done with it. Now, having said that, the first step is critical, labeling your input data file. You have to prepare the training data. So if I say I have 1 million records or 100,000 records of training data, I need to have it trained properly to say this is referenced. For example, this is a pricing issue, this is a network issue, this is a speed issue. Because like I said, the complaint is for a network provider, so I'm just going to stick with that example. Or any classification model for that matter. Just imagine your own scenario and see how you will train it. There are 3 methods. You can manually train it, which is going to take a lot of time. You need the expertise, you need the team, you need the manpower to do that, to sit and all of your team members need to be experts in understanding your data that well, that they sit and say, okay, this is a price issue, this is network issue. Imagine doing that for 1 million rows or 100,000 rows, how much ever your training data set size is. And then there's another method where you can do it through, I mean, Google has a service as part of Vertex AI where you can submit your request, you send it, and there are teams in Google that does it for you. This involves time, money, so that is another option. If you have both, you can do that. But again, you have to have the command over your business that you tell, this is, you set the business rules appropriately that the teams understand what you want to label them as. So your explanation or your expression of the business rules should be that precise and detailed that they'll understand and translate it for you in your training data. Again, the last method, this is my personal favorite one. This is what I would do, and that's what I've done here as well, is programmatically training your data. If you know the business rules that well, of course you can engage your engineering team to build that solution, to build that code that will enable you to programmatically, to automate it, automatically label your training data. So basically you can have some rules, or you can have some transformation logic and everything done in your Python code that will enable you to say, and you have to of course do a lot of analytics, a lot of ML, like you'll have to do word clouds, you'll have to do comparison, you'll have to generate keys. So it is minute work, it takes time, but at least you don't have to sit and manually label 1 million rows. Same thing, you don't have to spend a lot of money doing that. It's a matter of once you get a handle of how your labeling works or how your business works, it's a matter of just programming the steps for it, the rules for it, right? So that is what I have done here. I'm not going to show the, I mean, if needed, it's there in my slide, it's hidden, but if you want, you can also see the code, what I've used to label the training data, but that's the option I would use. Now, let's quickly see how this is done. The 5 steps that we saw in Vertex AI, let's see a demo. You can see it, or it's too dull? Okay, it's fine, right? You can see it. Okay, this is the Vertex AI console. So you go to dashboards. No, you just go to datasets, click create. So you create your data set from here. So this is what I said. You have your data set, right? Input file trained and ready. Step 1 is done. You have your training data ready. We are doing text classification. I'm doing a single label text classification. Select that option. So you need to know whether your problem is a classification problem or a regression problem. And then I'm uploading the file in this case. But according to our architecture, imagine that you have it in BigQuery. You can also do that. You can take the data from BigQuery. I don't have the demo video for it, but that's one of my most recent experiments. And then once you click that, once you've complete uploading your file or connecting your BigQuery source, create your training step. This is very simple. The click of a button, you choose your name for your training. You choose a randomly assigned split. I would be okay with that because Vertex AI knows what the split should be. Click Start Training. There are a few more details if you're using BigQuery, which you should provide about the database. So once it's completed, it'll take a few hours depending upon the volume of your training data. I'm happy with the evaluation results, so I'm going to do deploy to endpoint. So I've deployed. Now I'm going to get my URL, and I'm going to test. The same text that you saw in the beginning is copy-pasted here, and I'm testing my model. Prediction results are on the rightmost corner. You see it has identified speed issue as the one that has the maximum probability. So that is what it is. So typically, all that 1,000 lines just translates to speed issue. That's it. And if you notice here, this is one thing I wanted to show you. On purpose, I wrongly labeled that one text. I wrongly labeled it as overcharge issue, right? I wrongly labeled just to see, and the rest of my data was accurate. Training data labeling was accurate. So I wrongly labeled that just to see if Vertex AI will still will still take the training seriously and then get the right result for me. In fact, it was really speed issue, but I just wrongly labeled it in the input file as overcharge, and I ran the model, and ultimately, when you saw the results, it was the same text was labeled properly as speed issue, right? So that's exactly what I wanted to show, like how effective it is and how easy it is to achieve that. Imagine, I mean, you didn't spend a lot of time looking at, okay, what's my encoding step, or what I need to do to understand feature overviews, or what I need to do for tuning the parameters, hypertuning and all that. You did not do anything of that sort. All you had to do was just address the 5 steps and be an engineer, just do the 5 steps, experiment and see the results, consume the results in your application, right? So that's about it. This is one thing I wanted to show. Just a quick time check for the host. How much time I have left? Can I take a few more minutes? 10 minutes I have? All right. So this is an experience. So imagine that we have used all that we discussed. We used the ML part. We've used BigQuery for analytics, for visualization. We have used Data Studio. And we have also used the chatbot thingy, the dialog flow for that. And ultimately, we get an experience that looks just like this. So in the morning, I wake up, and as a service engineer, or as a whatever that I am, the engineer, I'm looking at classified data. I'm not looking at chunks of 1,000 lines of painful text. Rather, I get a classified format saying interruption 3 issues, overcharge 6 issues, and all. I'm interested in looking at speed issues, so I'm clicking that, and I'm looking at, you see, it's also, the 1,000 lines is also converted into a single line statement. It's not even, a label is done, but it has also summarized it. So I've used a BERT summarizer API to convert that as well. And then the chatbot, there is audio, but ignore it for now. Maybe we didn't set it up for it. I thought there was no audio, but yeah, this one has a bit of audio. This actually tells you, the chatbot speaks to you saying, okay, this is the issue, and this is how you fix it, giving you suggestions. So this is an experience, right? How would you compare this against the 1,000 lines of text that you have to look at, the painful text? Now, this is what we call like a proper user experience, whether it's for your developers or it's for your customers. And this is how the assortment of the Google Cloud technologies that we saw, services that we saw, will enable you to do that. So yeah, that's what I wanted. That was my point there with service, delivering experience as a service with Google Cloud. I'm not going to go into the detail of this one now because we have 10 minutes left. Not that I had planned to do it. I also wanted to just see if we have time, or if the group is interested. So I have linked my blogs around all these topics, so you can read about, these are all hands-on blogs, so you can just take like 10 minutes out of your time and follow it step by step, and you should be able to build and deploy your own Java Spring Boot application for any use case of your choice. Jib is used for building it, and also Cloud Run is used for deploying it. In this case, I've used Cloud Spanner. You can use whatever database you can use BigQuery as well, but I just wanted to show. This is the tech stack. Timeleaf is for the UI, the user interface and all. And this is the architecture. The reason, since we have a lot of full stack developers here, you'll probably be interested in this one. So this is built in 2 containers, one for the server API and one for the client interface, the user interface. The server API is deployed as container 1, and the client interface is deployed as container 2. And we have Spring Cloud GCP Spanner module library that connects to the Cloud Spanner database. So for that matter, whatever your database you're using in Google Cloud, you have the corresponding library that interacts with your containers. So once the container 1 is deployed and I have the API URL, I consume that in the client application to send requests and receive response in the format, hey, get the number of bookings, or post this booking, update this booking, and all that. You know how APIs work, right? That's what is done here. So that's about it. Okay, so the last thing which I want to talk to you about today is another thing that I said before. This is also around ML because the theme of the event is around that. So I just wanted to say a few things around doing codeless. When I say codeless, like you don't have to write Python code or anything for that matter. You can use BigQuery ML. And just use SQL queries the way you normally do to analyze your data to deliver an ML solution in 5 steps. So step 1 is creating your data set to store your model, just like we saw in Vertex AI. Here also you create your data set by clicking. Go to BigQuery console, click data set. Step 2, you take your input data. If it is from an Excel like we did, take it from an Excel file, upload it in the BigQuery database table. And as you can see, there is a query, there is a Cloud Shell command. Cloud Shell is something that you can use in Google Cloud. For all the console drag and drop options, there is an equivalent Google Cloud command. So here you can use the the Cloud Shell command, BQ load-source format. So you can use this command to actually load your input data into BigQuery table. And step 3, create a view if you need to. If all your training data is in one table, you can just do it without it. But if you're creating a view, that is the syntax for it. You can see that it's a plain old SQL query. Create or replace view, provide a view, and that's it. And the next one, step 4, is create your logistic regression model. This is not AutoML, by the way. You should know what model you're going to use. Whether it's a classification problem or regression problem. If it's a regression problem, what kind of model you're going to use, or what is the model type, what is the auto class weights, and all these. You need to know the definitions of it. But once you know, it's very simple. There's only like 5 or 6 parameters that are available, and you have to define all that and provide the options here, and that's the query. It's plain simple SQL, create or replace model, provide the options, and do a select SQL, because that is where your data comes from, your training data comes from. Step 5, so once you do the step 4, logistic regression model, the result of the model training is written into a table as well, a model under the models section in BigQuery. Step 5, evaluate your model. Again, use this query, select star from ml.evaluate. That's a table that you can see the results. And hey, the results look like this. You get precision, recall, accuracy. If you are in the data area, you would know what precision and recall is. If not, go and take a look. It's a really interesting concept. It's just to roughly say that it's about how many right answers you have rightly identified and how many answers you have identified that is right. So that is precision and recall. And accuracy is there. So this model came to about being 82% accurate. I don't know if it's, I have validated for a little bit. Yeah, it seemed accurate, but I'm not going to say like I'm an expert and I'm very happy with my results. There's probably people out here who would train it to be even more accurate or even make this 82% count. So anyway, that is your step 5. You see the evaluation results. And step 6, predict using your model. Now that we have a model created, you have to use it to predict something, right? So use the select star from predict. So what do you mean by predict something? Now you have your training data, you have your testing and validation data. Now you can bring in your own real-time data and have it use the existing model results and predict it using the select star from ml.predict step. Right? So this will tell you what your result is. In this case, I predicted it against prediction data frame set. I had, in my table, I had 3 sections, train, test, and predict. So I use train for training the model, for creating the model. I use test to evaluate my model. I'm using prediction for real-time testing or real-time predicting values. And it came to about, I mean, it was accurate. It was pretty much accurate for the data that I sent, but it's not many. I did like 2 or 3 tests, and that's it. So that's step 6. Step 7 is explain your prediction results. This is my most favorite part of all, because you have predicted, you have displayed your results. Now, how will you convince people that this is, in fact, how you got to that conclusion? This one will help you. This one will say, okay, with my local prediction results, like for example, explain predict can be done in 2 scopes, local and global. Local meaning, what are the factors that were considered for this particular row to predict this as prediction A or result B, for instance, right? So what are the factors that were considered for this particular row? That is what your local scope means. So you can explain, when you're telling your senior, your team, your leader, or you're telling your colleagues, like, this is my result, and they ask you, how did you come to that conclusion? Like, how do you know? So these are the fields that enable that. So you can go back and tune that to see your results change. And the next one is global explain predict, which means how the overall prediction result, what are the factors that the overall prediction result has used, not just that particular row. So that's the difference between local and global scope for prediction results assessment. That's about it. And before I close out, this is Cloud Run. I promise that I'll tell you how easy it is in 4 steps deploying your application. Anybody's used Cloud Run here? Okay, nice. Do you like it? Do you enjoy it as much as I do? Yeah. So in 4 steps, so what are the 4? Like I said, Cloud Run is used to deploy. It gives serverless agility to your stateless containers. And as you can see right here, there are only 4 steps. You declare the programming language that you want to use, and then you define the dependencies. You provide the start script, where your start script is, the CMD command, the last command, and then you write 1 Cloud Shell command to build and 1 Cloud Shell command to deploy. That's it. Your application gets a URL which is now running in the cloud, serverless, 100%. I mean, depends on what your database is. So when I say 100%, I have to be careful. If your database is not serverless, then it's not really serverless. But otherwise, your application part is serverless. So that is exactly what I mean. And Cloud Run lets you use any programming language or binary of your choice, and it builds down to $0, meaning you're charged only for the requests that you make, not for the amount of time that you actually hold the resources for. And Cloud Run Jobs is something that we launched in I/O 2022, just this year, a few months ago. Google I/O 2022, if you were watching, we launched this Google Cloud Run Jobs, which is to do monotonous background work that does not require much of user interference or user interfacing, like migration of database, cleanup work, importing and exporting data, running some scripts overnight, update scripts to a particular field, and all that, trigger jobs. So all these things can be configured using Cloud Run Jobs. And that's exactly what you can do. It's just like a scheduler. Again, for this, it will run only till the point your job is complete, and you will only be charged for your requests. And that's about it. Monitoring and logging, Prometheus, these are all the things that are part of the different aspects of software delivery. Like, of course, you have your application, you have your database, you have your ML solution. Now, how do you know which one is working and which one is not? What if something breaks? Like, you need to know what is breaking in the entire pipeline. So that is what fascinates me about cloud monitoring and Prometheus, is that cloud monitoring, logging, and all is groups, for that matter, is that you can group all your services that you're using for your product or for your solution, and you can monitor all of them in one place using this. So this is just a screenshot of where you can configure. For example, you can go to Metrics Explorer and define what exactly you're monitoring right there, what service you're monitoring. And you see groups out there that will allow you to bring all your services that your product is using and monitor them together as one big solution. So you know in one screen which one is consuming the most of your resources and which one is up and running, which one goes down. So it's all available in a single pane of glass view. So that's the best part about it. So I'd stop here. I know this was a lot, and this was way too much than what you were expecting from a keynote. But I'll just give you like 2-3 minutes. If you have any questions, I'll stop here and see if there are questions before I before I give it over to the next speaker.